So it's going to be definitely interesting. So enjoy the talk, and please welcome Philip.
Thank you. Okay, I know it's about lunchtime. I will try to be a bit entertaining so you won't fall asleep. So let's dive into monitor your containers. Just to get an overview, who was in my first talk about monitoring microservices? Okay, so don't be disappointed. This time we're jumping more into the Elastic Stack and kind of like the history. The previous one was more about programming. So let's dive into that. I'm still with Elastic, the company behind Elasticsearch, Logstash, Kibana, Beats, all the open source products. I'm part of our infrastructure team. So we do stuff like containers, AWS, testing with Jenkins, even though we like to call it Junkins. And would love to rewrite it, but that's a totally different story. And then that is kind of a Unix pipe. I pipe that into developer advocacy, so I'm doing lots of talks. Yes, and this talk is about logging all the things, in particular to containers, but you will see that. So, quick show of hands. Who has more than 10 servers, containers to monitor? Oh, there's quite a few. So how do you log? If you say SSH plus tail, that is the wrong answer. It just doesn't really scale at some point anymore. So quick overview. Who's using the Elastic Stack, Elk Stack already? OK, there's quite a few. Anything else? Yeah, those are the rich ones, yeah. We always have a place for Splunk users at Elastic as well. But let's not go down that alley today. So taking a step back, what are logs? For us, logs always, you have a timestamp, and you have something else. And that something else can be metadata, like what machine, what IP address, lots of other stuff, and probably a log message. But the main thing is you have a timestamp. At some point in time, something happened. And that is what we want to store and kind of centrally store and make searchable thereafter. So how do we go about that? This is kind of the 3-minute story of how we got here, since the Elastic Stack or Elk Stack is kind of well known. Back in 2010, Shai, our CTO, started Elasticsearch with the tagline, for search. And it was just for full-text search. And it worked well. It's very widely used. So if you search on any of these sites behind the search box, there is Elasticsearch doing the hard work for you, even though you probably don't recognize it. And then the next step was that there were 2 open source projects, one Kibana, one Logstash, who thought, well, this is a great thing. We want to extend it. The first one, Kibana, is the visualization part. You have lots of data in your cluster, and you want to see what is actually going on, and you just want to visualize that. It's kind of the window into your data. And then Logstash. Logstash is to get data, parse it, enrich it, and then store it somewhere else. That somewhere else is commonly Elasticsearch, but it can be different targets as well. We have like 200 plugins to read from different sources and write to different destinations out. So there are lots of choices. So those 2 were open source products, and we like to say we brought them into the Elastic family, because I guess their founders wouldn't want to hear that they were bought. So we stick to the narrative that they joined the family, and that is the well-known Elk Stack. And it's, it even got the plushie, like we even had the mascot, like the plushie elk. Elasticsearch, Logstash, Kibana, and that name was very sticky and everybody liked it. And it's also widely used. If you're at CERN and you log from thousands of computers, they're using that. Salesforce in the cloud, they're using it to log stuff. Goldman Sachs is a different story. They are using it mainly for auditing and compliance. So every now and then, Goldman Sachs does something bad and they need to pay a big fine. And at some point, they decided it's probably better to invest into an auditing platform and avoid paying the $100 million fine by investing $5 million or whatever into a compliance platform. And that is kind of their use case. And that worked all very well. until this little fellow came along. So the major downside with the Elk stack, especially with the Logstash, is that Logstash was started off as Ruby. Out of performance reasons, it was then JRuby. And you would always need to install the JVM on all your servers to collect your logs. And many ops people, if you're not a Java shop, are not too keen on just adding the JVM just for logging. And that was kind of recognized. So beats are written in Go. You get native binaries without any dependencies, and they are just like shipper or agents or forwarders or whatever you want to call them. So they are just something that's running on your system to collect information as efficiently as possible and forward that information and get it off your server. That is disappointing. What happened here? This is very weird. No? This is somehow screwed up. Let me open that again. That looks better. Whatever happened. So we added beats, and beats is great. The only problem is there is no B in elk. And we didn't kill the elk. That's maybe too drastic. Elk is in I don't know, elk retirement home or whatever. He's not dead. He's still living a happy life. And many people are still using the term elk, even though we try to get rid of that name. And internally, we have the so-called elk alert. Whenever somebody does a meetup, and they call it, we'll talk about the elk stack. Somebody from marketing will reach out and say, well, this is cool, but please rename it because we're trying to get rid of elk. And we tried to come up with something else. The first thing we had was this one. That is the belk or the elk bee. And you can see it's a bee and it has elk horns, and it's kind of the elk reborn and nicer. The only thing is it doesn't really scale. What happens if we need to add or want to add another product? We need to rebrand everything again and need to make up another animal. And it doesn't really work that well, even though many people really loved the belk. And one of our engineers was so enthusiastic, he even created stickers on his own. And some people even have those stickers on their laptops, even though they are very rare because he just did a badge for kind of himself. That was the first try, the belk or the elk bee. Then marketing went for the kind of boring choice. They said, well, let's just rebrand it to Elasticstack since that is the company. And whatever open source products we have, we will just stuff them into the Elasticstack. So if we come up with something new and exciting in a few months, it will still be the Elasticstack afterwards. And that's what the Elasticstack looks like today. So we have Elasticsearch in the middle to store your data, and that is where you query it. You have Kibana on top to actually visualize and interact with your data in an easy fashion. And we have Beats and Logstash at the bottom. So Beats is like the lightweight agent or shipper that is just sending data away. And Logstash is more of a centralized component that can do parsing of your data and enrichment. So parsing would be you have a log file, for example, Apache or Nginx or something like that, and you want to extract meaningful fields. These meaningful fields would be HTTP response codes, the URL. So you want to extract that to be able to search that in a meaningful fashion. And enrichment would be you have an IP address and you want to get the location of that IP address. And you do that once you try to insert it or get the data, store the location right away, and then you can very easily or efficiently query for all the users coming from the Czech Republic, for example. And we also recently had, a few months ago, a big version jump. So, for example, Elasticsearch jumped from version 2 to version 5. Because it's so much more awesome, so we skipped a few numbers. No, that was not the main reason. The main reason was since we had all these products that joined the family at different points in time, they all had their own version numbers. And Kibana was at version 4.something, 4.6 lately. And it was even for us internally very confusing, like what is the current version of which component? And if you ask me, like what is the right version for Elasticsearch 2.4, I know that is Kibana 4.6, and Beats 1.3 and Logstash 2.4. But if you want to know what is the right version for Elasticsearch 2.1, I have no idea, and I would need to look it up in, we have a big matrix to actually see what version works with what version. And we kind of got rid of that. So now everything is 5. We're right now at 5.1, and we'll very soon release 5.2. So all the products get released on the same day with exactly the same version number. And even if there is no change in the patch level release, every product will get the same patch level release on the same day to avoid any version confusion. And the other question commonly is, since a lot of that stuff is open source, so everything in that dashed line, the 4 products we've already seen, those are open source and freely available. You can just use them. They're Apache 2 licensed. How do we pay my salary? We have 2 things. Firstly, we offer Elasticsearch as a service hosted on AWS, but it is not what AWS is offering. That is actually a competing service. So that is Elastic Cloud. And then we have commercial extensions which go hand in hand with support. So that is kind of the business model behind it. So let's get back to containers and jump down to Beats and see what they're doing. So the first beat we want to cover is FileBeat. FileBeat, I always explain it like it's like tailf over the network on steroids. That is kind of the idea of FileBeat. It's really just like tailf. It's just taking something and sending it over the wire as quickly as possible and as efficiently as possible. You can then parse that. The beat does not parse anything. You can either do that in Logstash, or we have, in version 5, we have a new node type called ingest node that can also parse messages. But we're not going into the parsing stuff today. 3 nice attributes of the FileBeat is you have at least once delivery, so you will not lose messages. We support back pressure. If the receiver gets too many messages and cannot keep up, it can tell the sender actually slow down, wait a bit, send me more stuff later on. And we have graceful downtime. You will not lose messages during downtime. So how does it even work internally? So you have lots of servers, and you have your beats running on all your servers. They will then connect to either Elasticsearch directly or Logstash for parsing and enrichment. And you can see we have a few Logstash instances for redundancy, and the beats will just round robin between them and pick one instance that suits them, that is available. If one they try to reach is not available, they will try to find another one, and will just forward the data to those Logstash instances. How do we make sure we are not losing any stuff? So we have one file, and we have, for every file we monitor, we have a so-called registry file. And that registry file kind of keeps the pointer up until here we have sent everything. And that's the last bit we have sent has actually been acknowledged already. So the flow is beat sends a batch of messages to Logstash, and only once Logstash or the ingest node on the other side or Elasticsearch have acknowledged that message, that part that is yellow, the red part, only once it has been acknowledged, the gray area will be moved forward, and the registry file, the pointer, will be moved forward as well. Only once it has been acknowledged on the other side. If you do not get an acknowledgement, it will be sent one more time. So that's why we have the at least once attribute. And the nice thing is with files, since everything is a file, if the other side is not reachable, you can simply stop, keep the pointer to wherever you have been previously. And once the other side is available again, you can just keep sending stuff again. And since it is not in memory, there are no buffers that can run over. This even works across file rotations. So if you have a rotation policy, it will know, OK, I've only sent everything up until here on that file. You rotated it, and you will send the rest afterwards. More features. It can do multi-lines, so you can define a pattern. Every line needs to start, I don't know, with a square bracket, and then there is a date, but you only say square bracket. And if it's not a square bracket, then it's a multi-line statement, like a stack trace, which are generally a pain in the ass to parse. But you can at least package everything in a multi-line statement together. We can do client-side filtering, so you can log on debug level. But for example, you say, I only want to have centralized in my logs everything that is an error or a warning. you can both blacklist and whitelist in FileBeat. So you can say it starts with, I don't know, with debug, then just throw it away, don't send it over the wire to save some disk space. And we have JSON decode. If you are already logging out in a structured format, you can insert that directly into Elasticsearch. So you don't need any parsing anymore. That is actually what we kind of like most, because it doesn't make much sense to write a log message as a regular line and then needing to re-parse it again. It makes much more sense if you can actually write something out in a structured format already. So how does it work together with Docker? There are 101 options. So we will need to speak quite quickly now. Let's see. If you're looking at Docker, they have some logging appenders they support. That is the complete list. So yeah, there are some options. Which ones are relevant for the Elastic Stack? The first one is JSON file, which is the default what Docker logs out, which is nice because Docker logs still works. It's well integrated. It contains the metadata. Major downsides is logging JSON is potentially a bit slow, and the default configuration, even though you can change that, does not rotate files. So that log file will grow unlimited. Next up, syslog. Yes, you can run your own syslog server locally and just ship everything to syslog and can then get the data from syslog, which is very nice because it's totally configurable and you can rotate and it does everything. The major downsides are you need to run your own syslog server, and serializing and deserializing of multi-line statements is pretty error-prone, or you need to parse stuff again. So syslog can be a bit of a pain. Next up, journald, because there is no way around journald anyway anymore. The nice thing is it's widely available. It has metadata. It works with Docker logs. Major downside for us is we do not support journald yet. There is a community beat, so somebody saw the need and wrote a journal beat. FileBeat will be able to do that at some point in the future. No guarantees when, but we definitely have it on the roadmap. So in the future, journald will probably be your best choice. Then there is Gelf. There's a direct integration into Docker logging. Major downside is it's UDP. So you can lose messages. There is no back pressure, and there is no graceful downtime. For some use cases, that's fine. It's just like, OK, send as much as you can. If I have it on the other side, it's good. If I don't have it, it's no big problem. For others, losing log messages is still not great. And finally, luckily 101 was only binary, is you just mount a volume. If your application logs to something, you write to that mounted volume and have FileBeat collect the whole thing. Major downside is you're losing metadata. So today, the best option is generally JSON, syslog, or logging to a volume. In the future, once we support journald, it's probably journald. That's kind of looking into our glass ball and seeing what will the future hold. Next up, metric beat. Metric beat is a lot like top. It's just collecting metrics, but not just what top is doing, because previously it was called top beat. But it can do more metrics by now. So we have system modules, like that is what top used to do. But we also have application or service integrations. So it can just extract metrics from these applications. That is the current list. It will grow over time. So if you want to monitor some database like MySQL, Mongo, Postgres, metric beat will be able to do that. So it will know how many queries are you doing and how long are the queries taking and stuff like that. How does it work with Docker? You can just read cgroup data from proc, which is already part of the system module, which is very nice because it doesn't need access to Docker. Because the downside is once you can access Docker, and then you could start, stop, or do whatever with your containers. And probably your logging system should not be able to do that. So just reading proc is, from a security point of view, probably the nicer approach. Proc works on any kind of container technology, not just Docker. We can automatically enrich your processes with C group information. Major downside, if you're using Docker, there are no Docker names or labels because they are Docker specific. So you will lose that information if you just use proc. And then everybody screams, well, but we want to use Docker. Everybody just wants to do Docker. We know, or at least somebody from the community know. And they created a community beat called Docker Beat, which would just use the Docker API to collect all the information from Docker. And they had a 1.0 release, and they wrote a blog post on our blog. And I think within 2 days or so, Docker, the company, reached out and said no. Docker as the first part of any name, it's the wrong URL anyway. You'll get the right one in a moment. Because Docker said everything that starts with Docker is trademarked to them. You cannot, even if it's an open source, community, non-commercial, whatever project, it cannot start with Docker. So that was not so nice, and we reconsidered, and now you can take a picture. And we renamed it to DocBeat. At first, we thought even about just removing the E and just calling it Docker Beat. But I don't know. Somehow we decided to just call it DocBeat, or the community considered doing that. And since 5.1, it is actually part of MetricBeat. So you will use the Docker API now. The person who wrote it in the community was nice enough to actually contribute it, and it's part of MetricBeat now. So to get system permissions, you will need to grant these permissions to actually read from proc. Those are the volumes you will need for system permissions. If you want to monitor an application, you will need to link the container correctly. So for example, if you have some random MySQL container, to actually have MetricBeat collect information from, if it's living in one container and wants to monitor another container, that is how you will need to link it up so that it can actually access that information for you. And the general approach should be to run it as a sidecar and not put it into the containers themselves or run it on the host. That's not the ideal way. Run it as a sidecar so you can easily upgrade it or replace it or do whatever you want with it. And then there's the common question. This is one of my favorite comics. Like, okay, we have metrics now, and we're trying to store metrics in a full-text search engine. Is that very fast? And there are lots of benchmarks. Some vendors love to do benchmarks. Under similar conditions, for example, they benchmark the house cat against the squid in a tank of water, and obviously the house cat is dead. So their system, which is obviously the squid, will be much better. And this always reminds me, I think 2 years ago, MongoDB, Couchbase, and Cassandra each made benchmarks against the other two competitors, and each one of them managed to be at least twice as fast as their competitors, just by finding the right scenario. So we try to avoid doing benchmarks with competitors. But we have improved performance, especially for metrics, quite a bit in 5.0. So previously, we only had float, which is nice but a bit big. And then we have introduced half floats, so half the precision, but only half the space required. And we also provide scaled floats now. Scaled floats will just store an integer, but there is a scaling factor by which you divide the number to get back to the original value. For example, you could do scaling factor of 100, then it's just divided by 100. But it can also be like 400, 4,000, whatever. And that is your maximum precision you can actually store then. But it's, of course, a trade-off, less storage and easier to compute by doing that. Next up, packet beat. Nearly everybody, I guess, is using Wireshark. Wireshark is super nice as long as you have everything in one instance. But as soon as you need to monitor or collect network information on lots of hosts, it can be a bit of a pain. And packet beat is kind of the idea to circumvent it. It's using the same base library, libpcap, and collecting network information, and just extracts the meaningful information from the headers. So it will know something was a request, and this was the response for it. The whole thing took 20 milliseconds. The protocol was HTTP. The response code was a 200, and the URL you hit was foobar. And that is just passed from the network headers. You don't need to instrument the replication or anything. This is just extracted from the wire. So we support quite a lot of protocols. So you don't, for example, need to instrument your database anymore. It's just passed from the header information. So it knows, OK, this was a MongoDB request, and that was the response. It knows what was the query, how long it took, and it can extract all of that just from the network information. And if we do not support the protocol, or the protocol is encrypted, we cannot work magic, we have something called flows, so you will at least know who communicated with who. Like on the TCP level, you know this IP address with this IP address, how much traffic, how many packets, how many resends. So you will see what is going on in general in your network. And again, packet beat should be run as a sidecar. Don't push it anywhere else. Yeah, Docker containers. Do we have them? Yes, we do. Luckily, we started naming our stuff correctly from the start, so we called it Elasticsearch/Docker, and not the other way around. That was even before the incident happened. So in hindsight, that was the right decision. So we have Elasticsearch, Kibana, and Logsearch in Docker containers. The beats for the sidecars, you will need to build yourself at the moment. We will provide them soon. This is also part of what my team is doing. Though everybody's pretty busy with other stuff. So we'll soon start building these containers. Major thing to consider. So this is the minimal example to get Elasticsearch and Kibana up and running. I'm just linking them together. We're mounting ES Data 1 as a local drive. We're exposing the ports. Major thing to keep in mind here is we are using our own registry. If you search for Elasticsearch, Kibana, or Logstash on the Docker registry, you will get the Docker official packages, but not ours. To keep like a better overview of what is going on and who is downloading what version and stuff like that, we run our own registry. So only if you use our registry, you will get our tested packages. Otherwise, it's something done by the Docker community or by Docker themselves. Just as a warning, we often get complaints that stuff doesn't work as expected or we overlooked something, and often it turns out those are not our packages. So you will need to use our registry to actually get our packages. And the other thing is we don't have latest anymore. We did provide it at the very beginning, but then we quickly reconsidered because the assumption is you will start your cluster with 3 nodes today with latest, and in half a year or so, you want to add 2 more nodes. And if you're still using latest, you will probably totally screw up your cluster because you will just get any random version. Yes, I know it's very nice for testing to just use latest. But since people might do that for production, we are now leaning more towards being safe than sorry. So there is no latest anymore. You will need to define your version number explicitly. OK. I think we got like 10 minutes. Yeah, pretty much exactly. So I have that is like the entire Elastic Stack running. This is pretty much self-driving. So I've just put everything into a virtual machine. This is running Elasticsearch, Kibana, PacketBeat, MetricBeat, FileBeat. And I have a Docker container with Redis running, because MetricBeat is inserting its metrics into the Redis in the container and then store it into Elasticsearch. So if you have a very big system or you have big spikes or something like that, it is common to have your messages inserted into a queue. We support Redis and Kafka. Redis is normally for the smaller setups, and Kafka is for the huge setups. Or if you're based in Silicon Valley, you need to use Kafka because, I don't know, just mandatory there. Everybody is using Kafka in Silicon Valley. So we are inserting our metrics in here. Just to give you an idea what we're collecting. So MetricBeat is just very consistently pinging all the processes I have running and collecting that on the system level and the process level. So if I look at any random message, I have a metric set here. And this is actually monitoring the Docker socker and getting the CPU usage for that. But we have a field type, which is probably at the very end. Oh yeah, everything is metric set. That is not helpful here. We could, for example, find the data set just for the Java processes. And it's searching. And we found 180 entries for Java. And that is one single process that is running on my system. And you can see, okay, that's the Logstash service. Since it's JRuby, it's running in the JVM. It's one of the Java processes. That is all the information that is actually stored. So you can see all the C group information and the general memory and CPU usage information. That is all stored per process. This is a lot of information. If you do not intend to use that information, do not store it. Because if you have lots of servers, this will be lots of storage you will need. Just try to keep that in mind. And otherwise, don't complain that it's taking too much memory. But you can see, okay, what are the options you have started? What is the memory usage? What is the CPU usage? You can find out all of that information from here. And we provide some pre-built dashboards. So for example, if I open the dashboards for processes, you can see, okay, we have 90 processes running. And that is probably too small for you to see. But little surprise, that big thing here, that is the memory usage. That thing at the bottom is Java. It's taking up some memory. Any guesses which processes on my system are running Java here? Elasticsearch and Logstash, since it's Ruby. Next thing that is taking up some memory is Node. Any guesses what Node is? Kibana. Node.js, yes. But the process that is running Kibana, the visualization, that is a Node app. And we have the beats. You can see PacketBeat is using some memory. I have MongoDB running. Dockerd is taking up some memory. The Redis server is very slim. FileBeat is also very slim. And I'm collecting, since I can show you that as well, we are collecting. Oh no, we don't have a log message with Java in it, so let's see. Those are all the log message I've collected, so I think I have only 3 log. So I'm taking the Docker logs and I'm taking the Kibana logs into my system. That is probably very small for you to see. I can try to make that a bit bigger. Yeah, but that's breaking down. OK, and here, for example, I could say I'm only interested in the Docker logs now. So you can just click that plus sign and you filter down just to the Docker logs. You can see, OK, every now and then we have a few Docker logs. And we could, for example, look down into one of them. And you can see, OK. Redis logged some message out here. I have simply, in my example, I'm using the default logging, so to JSON log files, and I'm simply collecting the JSON log file that my container is emitting. And that's the way I'm just getting whatever my container is doing here. OK, so those were the processes. We can take a look at the containers as well. So on my system, I'm a bit lazy. I just have one container running. That's my Redis, using very few resources. But if you had more containers, you could see what each one of them is using in resource-wise. You have running, pause, stopped. You can see how the volumes are nested. And you can see CPU and memory usage of that one container and network usage. And if you had multiple containers, you could see the aggregated statistics. And you could even filter down to each single container to see how that one is doing. So this is one of the visualizations we have built that is provided by default. And the final bit I should show you probably is we have PacketBeat dashboard. So that is all the network traffic I have. Client location will be empty since everything is running on localhost on my machine, and there is no good GeoIP lookup for localhost. So that one is empty. But you can see we have a few web transactions. The web transactions here, that is actually the Kibana calls. So I'm monitoring my interaction with Kibana that is driving the web transactions. Database transactions, I have MongoDB running here. And cache transactions, that is what Redis is doing in the background. So we are monitoring all of those. And you can see response times, most of them are very quick, up to 10 milliseconds, and a few ones are a bit slower. We also do percentiles, like 99 percentiles go up to 500 milliseconds, but everything else looks pretty decent. Very few errors, errors over time, latency histogram. And we have specific introspections, for example, into web. You can see, okay, those are all my web transactions, 324 in the last 15 minutes. Those are my top URLs. The error codes, I had 404 error, and those are my most common URLs. And all of that information is just extracted from the network headers. So you don't need to instrument your application in any form. It's just like HTTP headers, and you just parse that apart and get all of that information for free. Or we could look at MongoDB. I'm not running any meaningful MongoDB queries, but you see, okay, no errors since there are no proper queries going on. It's just being pinged, so you can see, okay, it's doing some traffic. If you had errors, you could see them, and you can see your top queries. And again, this is just from the network interface. So we're just parsing the header information from those calls. And yeah, we're not running any too interesting results. Redis should be a bit more interesting. Of course, you can search here as well, if you can type. So we have a very stable connection of up to 3 clients. I'm not actually sure what is 3, because on the one side I'm writing in, on the other side I'm taking it out. I'm not sure which side is taking 2 and which one. But you can see we have one Redis server with that version. It's a standalone server, and the only command we're running is epoll. But again, just network information, and you can actually see what one or all your Redis servers in your network are doing, or whatever database service you have. So, to sum up, I'm always comparing the Elastic Stack to Lego. You have kind of all the building blocks, but you need some assembly. So you cannot just say, okay, start this thing and do everything automatically. But you will need to kind of put the right bits and pieces together. The main advantage is you can use it for pretty much anything. So you can use it for log management, for metrics, but you can also use it for your business data. So whatever business transactions you have, like visitors on your website, signups for your newsletter, all of that stuff you can collect and visualize in Kibana as well. But it will require some upfront work. Everything in the dashed line is free and open source. You can just use those. Right-hand side is the commercial plugins, and at the bottom, if you want to have it hosted, we're happy to do that for you. Currently, AWS only. Might change in the future. Yeah, and we always say that the story, if you want to get deeper into it, most people start on the open source side. Then we offer trainings. We do development support, consulting, and support. Even though we don't do implementation consulting, we just do like architectural reviews. But of course, we do 24/7 support of your clusters, and especially for the bigger customers, that's one of the nicer things. So, I think we hit the time pretty much exactly. I can do more demos like for 3 minutes or something like that. So one nice thing that is also pretty new is TimeLion. TimeLion is for time series data. Let's make that one a bit bigger, since we only have one. So this is, time series is just, you can either just count documents or you can go into a specific metric. Here, for example, I have just all the documents I have in my cluster. So I'm inserting about 300 events per second. Now, I would like to know, like, what is mainly driving that? Is it metric beat, packet beat, or file beat? And you can actually split it up. So you can say the index I'm interested in is file beat. The next index I'm interested in is metric beat. And the last one is the next Elasticsearch index is packet beat. And you can run that and you see everything is queue. So that is not very helpful. So we can actually label that. One of the nice attributes of this one is it will actually, you just type a dot and it will suggest all the things it supports. So you can just say label, and I'll call that packet, and I'll call that metric. And you can see, okay, packet beat is doing most of the interactions. Metric beat is very stable and doing also a lot. And file beat is just randomly ingesting some files. So that is a very nice overview to see who is responsible for what. And you can actually then dive into the data and see, I don't know, how is my latency going? How is my response time doing? Everything that is number-based, basically, you can graph out very nicely over a time series. OK. Since we're out of time, any questions? Yes?
So how do you log software problems like core downs, microexceptions, like that? Do you have any special runtime for this kind of thing?
Sorry, how do we log stack traces? So
software problems like core downs or until Python exceptions. Do you have any special questions?
yeah. So the question was how to log core dumps and stuff like that. So FileBeat will just collect anything where you point it to. So wherever that goes, though it probably doesn't make much sense to collect an entire core dump and make that full text searchable. I don't think that is the best use case for log management. You will have the general event in your log probably, which says, I don't know, crashed, here's the core dump, whatever. And then you can dump into that. So you can define a search, and you can store the search in the interface and just show me over the last week or whatever all the core dumps I had and find those. But the core dump itself, you probably would not put into Elasticsearch. Since it's all full text search, you can just define whatever pattern you have to search overall the log files and then find whatever you have. But you need to know what you're looking for. There's no magic, like it knows what that thing is. But of course, you can then visualize it and graph, for example, everything that is log, debug, or whatever. So you can graph it out over time, and you see, OK, oh, there we have more errors. And there we had fewer errors. And then you can just dive down into where bad stuff is happening. Yes? Yes, there is an alerting feature, and it is part of XSpec. Sorry, the question was, is there any alerting feature? Yes, it is even called alerting, but this is part of XSpec, the commercial extensions. That is where my salary comes from. And alerting is a very nice feature. You can just define a threshold. It's basically cron-based, so it will run every minute, every 5 minutes, whatever, over your data set. And check, is a specific condition met? Like, is my cluster in a bad state, or do I have specific messages? Or have I breached a specific threshold? Like, do I have more than 5% 500s in my logs? And then you can define a rule what to do. That could be email, Slack, PagerDuty, webhook. I think we can now even create Jira tickets automatically. I don't know why, but some customers must have really wanted that feature to create tickets automatically. I don't think it makes much sense, but we can do that, yes. But security, monitoring of your cluster, alerting, graph to explore your data, and generating PDF reports, those are commercial features. And they always come with support. Pricing model is generally per node. So we're not like some of our competitors volume-based, but it's really only per Elasticsearch node that is what counts. Any other questions? Yes?
I'd like to ask you about the future.
Yes.
Could you be a bit more specific as to when can we expect Journal D integration?
I have talked a few months ago with the colleagues on the Beats team. Sorry. The question was Journal D support. We don't know. Like, even if I probably couldn't tell you if I knew, but I honestly don't know. I don't know how it's prioritized on the roadmap. They are pretty active. Like, for example, the latest release brings inputs for Prometheus. So you can use Prometheus endpoints and collect that data via Beats into Elasticsearch. And there is lots of stuff going on. There is a new beat to actually ping your services now, but I don't know really when journald beat will be available. But I understand that it makes total sense that you don't need to write out two log files anymore and then read the log files anymore, but you can query journald immediately. We get it. I have no idea when it's implemented, unfortunately. I'm sure there is an issue, and you can watch the issue and get notified when something is going on. In the meantime, since there is the community beat, try that. I honestly haven't tried it. I don't know how good it is, but I assume it's workable since it's a common requirement. Yes?
I'd like to ask if the setup using Docker containers for Elasticsearch and other stuff, is it supported for production use case, or is it just for...
And the question was, are the Docker containers supported for production use case? That is an interesting question. I know we had lots of internal discussions around that. I think, so the point is, just using Docker containers does not buy you much normally, because the orchestration is kind of the major issue. So if you just use the Docker containers, we will help you with your containers, but we will not help you with your orchestration, since that is yours and we don't do that. I don't know if that is a yes or a no for you now. So our point is pretty much Docker does not solve most of your problems because you have persistent data and upgrades are still an issue. But internally, our cloud uses Docker containers as well. So we have worked around that, and we totally support that. But we do not want to get involved in your orchestration. It's kind of like the orchestration wars. We do not want to meddle in there and get kind of lost. That's not our core business. Yes?
Is there any chance that there will be some kind of PCP, performance copilot beat?
The question was, will there be a, sorry, what, a PC?
It's also for matrix collection. Like we have the matrix beat, but it's basically another system for matrix collection.
So I wouldn't be aware that we are planning anything. But of course, quite a lot of the beats start in the community, and if it makes sense and is widely used, we might be willing either to rewrite it or take your existing code if that is okay for you. So I think there are 3 or 4 dozens of community beats by now. So people are writing their own beats for whatever makes sense. So somebody has written a Twitter beat, so you can collect tweets, which is probably more of an exercise to show how it's working in general, or Hacker News or whatever. So you can always stay in Kibana and pretend to be productive while you're just reading Hacker News. So it's totally possible, but we don't support it ourselves yet, which doesn't mean it won't happen. Any more questions? I think we have time for one more. No? Everybody good? Perfect. Grab stickers. Thanks a lot.
Raz, jedna, raz, dwa, raz, dwa.